Hey guys, I know some of you guys were confused on the production of X-rays, so I'm gonna kind of briefly go over it, try to dumb it down and try to make it easier. And I'm gonna be reading off the slide when it comes to like reading off the steps, but I'm gonna be explaining every step so that you know what it's talking about. Because I feel like it's much simpler than it is, but it uses a lot of terms, so I'll go over that too. So, some of these things you do have to memorize, and I'll tell you which ones, but the things that you do have to memorize are voltage, and I'll get to that in a second. But we're gonna go ahead and start with step one of production of dental x-rays, which is slide number 46 is where I'm gonna be starting at. So it just says electricity flows from wall outlet. It supplies power to generate x-rays, and when machine is powered on, the electrical current travels through the cord and enters the control panel and moves through the wires in the extension arm and the tube head. So this part I think you guys already know, but just for visual, all that slide is saying is that the electricity just travels through that power cord there. Through the cord, it's gonna go straight to this control panel. Through the control panel, it's gonna go straight to the extension arm, and then it's gonna go straight to the tube head. So all it's saying is it goes in this order on how the energy is, the electrical current is going through. So from the cord to the control panel to the extension arm to the tube head, just goes in order. So now let's go ahead and go to step two. So this is kind of where it gets confusing, just because it starts to use some of the terms that it mentioned in the couple slides. But it was saying, let's see, so it says step two, the current is directed to the filament circuit and step down transformer. Reduces 110 or 220 line voltage to 3 to 5. So what a filament circuit is basically a fancy term for just high voltage and low voltage. So when we try to expose x-rays, it uses these two types of circuits. So we're gonna use a low one and a high one. And I will go over those and when they're used. So yeah, sorry. So it says reduces 110 or 220 line voltage. So this number here, 110 to 220 line voltage, this is just a general number of what type of voltage the tube head has already. So this is just a standard number right here. So it's basically just saying that the electrical current that we're getting, the electricity we're getting from that power cord right here, and how it goes through all these right here, that electricity is always going to be 110 to 220 voltage. Like that's always just a standard number. But yeah. And then when it says the voltage goes to 3 to 5. So this is where it starts to get confusing. So after, just like we mentioned here, after this cord here, so again, electrical current, gonna go through the cord, through the control panel, to the extension arm, to the tube head. Because we turned on the unit, and because it already has electricity because of that cord, the standard voltage is 110 to 220. This number, she didn't want us to memorize. I did ask her about that, but I'm not sure. Maybe you guys can ask her too. Because that's just the standard voltage. When that electricity travels through that tube head, it's gonna hit right here. So it says it's directed to the filament circuit and step down transformer. So it's gonna hit right here, and I'll show you guys. It's right on the thing. That electricity is gonna go right here first. So this is step one. It's gonna hit that step down transformer. When it comes to the terms, you do have to memorize that what high voltage and what low voltage numbers they have. So the 3 to 5, it's always gonna be low voltage. 3 to 5, and that goes hand in hand. So step down and low voltage go hand in hand. So a step down transformer is also 3 to 5, and a low voltage is always 3 to 5. Okay, so if you just memorize that, you'll know that voltage when it hits the step down transformer. So we went from 110 to 220 voltage from just the regular electrical current to 3 to 5. Why did we go to 3 to 5? Because we went right there. It hit the step down transformer, the electricity. Once it goes to that transformer, it just goes in order on where it's gonna hit next. So in the second step here, it does say that the filament circuit. So it's gonna hit over here. So basically, the steps are just letting us know where that electrical current is going. So we went from the cord to the control panel to the extension arm to the tube head to the step down transformer. When it hits the step down transformer, it goes from 3 to 5. We're at 3 to 5 right now. After that step down transformer, it's gonna hit that tungsten filament circuit, okay? Which is that little blue thing you see in that X-ray tube. Because the electrical current hit here, that's gonna heat up that little wire that it has on there. So let me delete this. You see that little wire in there? That starts to slightly heat it up. And that's the whole reason. Maybe you guys have a question about this, but you're kind of wondering like, well, it's 110 to 220 voltage and it went to 3 to 5, so how does that heat it up? Well, the 110 to 220 voltage is way too high and it'll burn out the X-ray tube. So that's why when the electrical current, when we plug in that X-ray machine, that's why it goes to a 3 to 5 voltage. That's why this number goes down. Because if it's this number is way too high. So if it hits it from 3 to 5 only, it's enough electrical power to heat up that filament, because that's the goal, is to heat up that filament so we could get electrons. So that's why it automatically does that. That's why they kind of built the X-ray machine like this, because 3 to 5 voltage is the minimum amount of voltage we need to heat that up. That's the whole reason why it goes down, or else it'll literally burn out. It's too much. All right, so we're at 3 to 5. It hit that filament there. Because it hit the filament, it has a wire there, and that heats it up. So that's where we're at right now. Now we're in step 3. So the filament circuit uses 3 to 5, just like I mentioned, to heat the tungsten filament, what I just mentioned as well. So through thermal ionic emission, electrons are released from tungsten filament when electrical current passes through and heats filament. So because that is heated, now it can generate electrons. So these little guys are electrons. Okay, so we got electrons from the heat, from that 3 to 5. And now it says the outer shell electrons of the tungsten atom gain enough energy to move away from the filament surface and create an electron cloud around the filament. So once that filament is heated up, initially they are around the cord, but then they start to kind of like go over here and they start to kind of form this cloud around the filament. So that's all it's saying there for step number 3. Electrons stay in the cloud until the high voltage comes in. So again, we're still in low voltage. Always remember, low voltage is always 3 to 5. Just remember that number, 3 to 5. So because we don't have enough power yet, those electrons are kind of just freely in that space, in that purple circle here. So they're just freely in that space waiting for the high voltage so it could shoot out. Okay, so now let's go to number 4. When exposure button is pushed, the high voltage circuit is activated. So that's what activates high voltage. So low voltage, again, 3 to 5, which is the step down transformer. High voltage, and this is in your previous slides, but remember this number as well. High voltage is 65,000 to 100,000 voltage. So you see how that number increased by a lot? This is our high circuit here. Our high voltage. Okay? So it literally went from 3 to 5, right? It doesn't go into the high voltage until we press that exposure button. Once we press the button, it goes from 65,000 to 100,000 voltage. Okay, that's all it's saying there. And then the next one, now that you know that information, the next thing makes sense. Electrons produced at the cathode are accelerated across the X-ray tube to the anode. So all it's saying is going from negative to positive. Okay? So always negative to positive. Never forget that. So always negative to positive. So it's literally just shooting out to that side there. And then it says the Molly B. Denham cup in the cathode directs the electrons to the tungsten target anode. So now let's go to this next thing here, right here. So right here you can kind of see it better. You can see that wire there better and everything. So all it's saying there is that this cup right here, so in the cathode, so remember it's always negative here, positive here. So cathode is always negative. It directs those free electrons, she actually drew one for us here, to the tungsten target filament. So it's shooting out to this thing here, and I'll put it in red. So that's all it's saying. With that high voltage, we went from 3 to 5 to 65,000 to 100,000. It's gonna shoot it out to this tungsten target, okay? That's all it's doing for step number 4. Okay, let's move on to step number 5. So electrons travel from cathode to anode. So we mentioned that. Electrons strike tungsten target, which we mentioned that. Right here, she kind of just put information on what happens when that target is, when it hits that target. So it says their kinetic energy is converted to X-ray energy and heat. So that all she's saying is that's what's happening when it's striking it. And basically, we only get 1% of X-ray energy and 99% of lost heat. So this I did memorize because, to be honest, I don't really truly know what that means. But all I know is that we have 1% energy after that's done, and we have 99% of it lost. And I think this is because we're just using such a high voltage that we lose a lot of it. So remember, it's 65,000 to 100,000 voltage. So that's what's happening in step 5. Step 6, it says because there is heat, because of this high voltage, there's gonna be a lot of heat. So that's where the copper comes in. So copper, this right here, what this does is it carries the heat away. That's all it does. Copper carries the heat away, and the oil inside so if I go up here, sorry, the oil here, this is what absorbs that heat, just so that the tube head doesn't overheat, just because we're such at a high voltage that's why they add that copper there. So again, the copper, it carries away the heat, and the oil absorbs it. That way it kind of, it's more neutral, the voltage is not too high in there, and it doesn't burn out. Okay, now it says X-rays produced are emitted from the target in all directions. The leaded glass housing prevents the X-rays from escaping the X-ray tube. A small number of X-rays exit the tube through the unleaded glass window portion of the tube. So all that is just a fancy word for saying that once we go from negative to positive, you know how it shoots out like this, just how we said. Well, now, because it's shooting to the tungsten target, we get a bunch of like scattered things here, scattered electrons. So that's why it says X-rays produced are emitted from the target in all directions, like that. But that's when other components come in. So the leaded glass housing, which is, I think it's on this one here. So the leaded glass housing, actually, sorry, I think it's in this one. Pretty much this is all made out of glass. So that's what prevents the X-rays from preventing to come out of this right here. Remember, this is the heart of the X-ray. This is where electrons are at. This is what's gonna produce that X-ray. So that's why it's glass and it's leaded, so that the electrons here, where all the arrows are, they don't escape all this, because then we're just going to have scattered radiation when we expose the x-rays. So that's why they make that glass, so it's kind of just going inside that glass, it's not going outside over here. And then it says a small number of x-rays exit the tube through an unleaded glass window. So this is where that other one comes in here. This unleaded glass window right here, that's where some of that beam comes out. So only a small portion of that beam is going to come out. And this is important because this makes a straight line when we expose the x-rays. That's why we get a nice clear image there. So then that leads us to the next step. So x-ray travels from this unleaded glass window to the tube head seal, which is this little thing right here, to the aluminum discs, to the lead collimator, to the PID. So it's just saying the order of how the beam is coming out on step 7. And if you take a look at the picture, it kind of like you can see in what order it's going. So here, let's say the order again. So it's gonna go from the unleaded glass window, let me make that smaller, unleaded glass window to the tube head seal, so here, to the aluminum discs, to the lead collimator, and to the PID. That's all it's saying there. And then the beam is gonna exit. And that's how they produce. So kind of like a little recap. Turn on the unit right here. It's gonna go through the cord, through the control panel, to the extension tube, to the tube head. In general, electricity is from 110 to 220 voltage. So that electricity is gonna go to the step-down transformer. The step-down transformer is always 3 to 5, so it's gonna reduce that voltage so it doesn't burn out. From the step-down transformer, it's gonna go to the tungsten filament circuit. This is the high or low voltage. We're still in low voltage because we're at 3 to 5. That 3 to 5 is enough to heat that coil up, and electrons start to cloud over. After the electrons are clouding over, we're now waiting for the high voltage. Remember, we get the high voltage from the exposure button. That's why we expose them from there. The exposure button is the high voltage. High voltage is 65,000 to 100,000 voltage. So it goes from 3 to 5 to all the way up to that number, 65 to 100,000. Okay. The high voltage is gonna go ahead and shoot out those electrons to the anode, to the positive side. Once it goes to the anode, remember the leaded glass once it goes to the anode, it's going to target the target filament, which is the tungsten target, which is right here. When it goes to the tungsten target, it is going to scatter everywhere. That's where those little arrows are. But because it's made out of glass, it's going to keep it in that tube head, and it's only going to come out from that little window. Okay, that little window here. And that's where the order comes from. So we're going to go from the window to the tube head seal to the aluminum disc to the lead collimator to the PID. And that's how they are produced. Let me know if you guys have questions. I know it's a lot, but kind of think about it, how electricity is going and what's happening in every step. But let me know if you have questions.